Hello everyone. In this video we will be talking about internal forces. So here in this picture over here we have a design as such. It's connected to the wall. We have force P1 in this direction, talking about this one, and force P2. Now let's say we want to know what are the internal forces on this line AA over here. And also I want to make a cut at A. So what are the internal forces there? So let's look at it over here. So we have AB. Now what do we have on A? We have a reaction force upwards, AY, a reaction force AX, and a moment. And we have the same thing, MB, NB, and shear at B. Now we know if we do the equilibrium, AY equals VB. Otherwise, this part would not be in equilibrium. The same thing as AX equals NB and MA equals MB. Now it's the same thing if we just do, I guess, from going from B till the end. This is over here. So we have the same reaction forces VB, NB, I'm sorry, the same internal forces VB, NB, and the moment MB. And we have here P1, P2, so we can do the same thing. Sum of fx equals 0, sum of fy equals 0, and sum of the moment equals 0. Now let's take for example here this example. Let's say we wanna see at B. So first we need to find AY, and we have dy dx. Okay, so let's find AY first. The way to do it, we can just do sum of the moment at D equals 0. So we only have the 6 times whatever distance this is equals AY times, let's call this big D, from here to there equals AY times D. So we should have everything. We get AY equals blah blah blah. So now if we do the same cut as we did before, we have AY here. Now this is B. So what reaction are we going to have there? We're gonna get VB and the same thing if we wanna keep going at C. Now we have AY, we have 6 over here, and then at C we have, let's assume it's on the upward. Actually, ignore what I said over here. We will not be talking about this yet. This will be later. Now we will see how we can actually get the internal forces. Now moving on. So now I will talk about the topic how to draw shear force diagram and the moment diagram. So let's say we have this part, we have here reactions AY, AX. Now directly we can see that AX is 0. We have this distributed load W, we have P. Now W ends at A, and the force P is at B, and let's call this big. Now to draw a shear diagram, so basically at point A, what force do we have? We have the reaction AY, and it's upward, so it's positive, so this is AY. And then it's going down with a slope of W, right? Until point A. So this force here is gonna be AY minus W times whatever the distance. Let's start from 0. So W times A. And then we don't have any forces here. So then we have a straight line here. Now at point B, we have a drop down by P. So this force here is going to be AY minus W times A minus P. Then we don't have any extra forces. Then actually here we have a reaction BY. And then it's going to go by BY. And this always ends at 0. Otherwise, we would not have equilibrium. So now, to draw the moment diagram. So here, let's say the moment. Now we don't have any moment reaction at A. So we're gonna start at 0. And V is the slope of the moment M. So think about it. V, this value is the slope of the moment. So what do we know? We know V is going down, right? So how do you draw a line with the slope keeps going down now? It's gonna be a parabola, either like this or like this. Now what's happening with the slope here is going up, right? It's increasing the value. And now here the slope is going down, so the shape is gonna be like this. So as you can see over here at A. Now here we have a straight line. That means the slope on the graph of M is gonna be the same. So it's gonna be a straight line, and then it's gonna go up by all this value over here, and then it's gonna drop down with another straight line all the way to the end. And notice it also ends at the value up to 0. Otherwise we won't have equilibrium. Now moving on. So as I was discussing before, now W dV dx is actually the distributed force, and if we want to get the shear from that, we simply do the integral. And the same thing, the M dx is V. Then if we want to get the value of M, we just do the integral. Now remember what I was talking about, the slope of M is the value of shear. So if we have, just like I talked about before, this is Vx, so if we have a straight line. Now notice this is a positive value. So let's say it's going to be a straight line with a positive slope. Now if we have something like this, it's going down, it's positive, so it's going to be something like this. And notice if it's actually dropping down to 0, we have the 0 slope over here. And then we could maybe have, well, in this case we will have to have a reaction moment here that's gonna drop the value down to 0. Now let's keep going with this. Now all of these problems really, it's all about practice, and then you get used to it. So I guess we can do it 3 quick examples here. Now I won't really put any values because it's gonna, the main thing is to know how to draw this, and then the values is gonna be small. So here we're gonna have a reaction. Let's call it AY and BY, sorry. Now we're gonna start at AY, and then notice this is W. Now W is negative and with an increasing value. So how do we draw a negative slope? Like this, right? Going down. Now the slope is gonna be changing. So we're either gonna have a parabola like this or a parabola like this. Now both of them have a negative slope. But since the slope is increasing here, being more negative, it's gonna be this one. So it's gonna keep going. There's nothing happening, nothing happening, nothing happening, nothing happening until we get here. What do we have? We have by. So it's gonna go up until 0. Now notice this is actually gonna be the value of by. Now if we wanna draw the moment of this, we have x moment, so it starts at 0. And notice first it's gonna be positive, and the value is decreasing. So it's gonna be like something like this. And then it's negative, and the value is increasing, so it's gonna be this shape over here. And it's gonna be like this. And notice it always ends at 0. Actually, I'll do one more example. Now here we only talked about this one. And now I'll do one more example here. So let's say we have this shape. Now at A we have AY, BY. Now we can draw, we have shear X. Now what force do we have at this point? We don't have anything, so it's 0. And we have a distributed force here, distributed force here, and a distributed force here. So first, the distributed force is negative, and the value is increasing. So it's going to be like this. Notice how the slope is getting more and more negative. And then over here we have a reaction AY, it's going to go up to here. And then we have a constant same value, -2. So it's going to be a straight line. Let's say something like this. Then we get this is point B, this is point A. And then we have a decreasing slope. This is a decreasing. Now notice the difference between this and this. You see how here we have an increasing slope and here a decreasing slope. Oh, sorry, actually I did a mistake here. Oh, my bad. Let me erase. Yeah, and be careful. It's very easy to make mistakes in these problems. It's very easy to think you have something different. So we have, this is the axis. Now this is point B. Now actually here at point B it's gonna have to go below the axis. So it's gonna go here and then it goes by BY and then it goes back to 0. Okay, let's do that. Let's go over that again. So we have shear and x. So first slope is negative, slope increasing its negativity, and then we have it goes up by AY, then it goes with a constant slope. Notice how it's a straight line with a negative slope, then it goes by BY and then decreasing with a negative slope and a decreasing slope. Now if we want to draw the moment, so first it starts at 0. Now we have here negative and the negativity is increasing, so it's actually going to be the same thing. Then it gets to point A where it's positive, decreasing positivity. It's gonna go until actually this point. So let's say this point is here. It's gonna go like this. And then it's negative, increasing negativity. It's gonna go back like this. Positive, decreasing positivity. I'll draw that again actually to have it look a bit nicer. So we have moment X. It's gonna get negative, increasing negativity. And it goes up. down, then up. So again, with these problems, you're gonna have to get as many practice as you can. Once you get used to them, it's really simple. It's a bit hard at the beginning, but then once you get used to it, they're very simple. Alright, thank you everyone for listening.